Speed and velocity. In this video, we're going to look at what is speed and how is it measured, what is the difference between speed and velocity, and what do we mean by the term instantaneous velocity. So speed is how far an object travels in a given time interval, regardless of direction. That's what we mean by speed. So speed is distance divided by time, distance traveled divided by time. So if a car travels 240 kilometers in 3 hours, its average speed is 80 kilometers per hour. We call that the average speed because we don't know if the car is actually traveling at a constant speed or not through that distance of 240. All we know is we traveled 240, we traveled that distance 240, and it took 3 hours. Possibly the car stopped and then traveled faster, but overall the average speed is the total distance divided by the total time. So average speed, distance traveled divided by time elapsed, and we either symbolize that with S average, speed average is equal to distance divided by time, or some people for the average just put a bar over the S. So S bar is equal to D divided by T. Now the terms speed and velocity are not synonymous. They're not synonyms. Speed is a positive number with units, whereas velocity is a magnitude, a numerical value. That's what the word magnitude means. So it's the magnitude of how fast an object is moving and in what direction it is moving. Some people say that velocity is speed with direction, and that would be a good way of remembering it. So if we have a person walking at 5 meters per second, the way I have it drawn here, speed is just simply 5 meters per second. It's a number and a unit, but the velocity would be its speed plus the direction of travel. And I've written that the direction of travel is 30 degrees north of the east line. In the future, I'll spend some more time talking about the direction and the notation that we use. But just for now, understand that speed is just distance divided by time, where velocity is speed and direction. For average velocity is displacement divided by the time elapsed. So one way of figuring out the displacement is identifying the final position and subtracting the initial position, and then dividing that by the time elapsed. So average velocity is the change in position, I'll call displacement, divided by time. So that would be x2 minus x1, final position minus the initial position, divided by the final time, divided by the initial time. Often the initial time will be 0, so you're just subtracting 0 from whatever the final time is. So here's an example. A person walks 85 meters east and then 32 meters west, and the entire trip takes 65 seconds. So I have this drawn such that to the right we're going. I'm going to add directions here. It's always important. So we're traveling to the right 85, and then we're traveling to the left 32. So speed is total distance divided by time. So the total distance would be 85 plus 32 divided by 65 seconds, which is the time interval. And that works out to 1.8 meters per second. That's the speed that you're traveling from here to this spot right here. That's the end. Now, average velocity is displacement divided by time. So the displacement is this region right here. That would be the displacement. I'll do a X right here. That's our displacement. So you see our displacement is smaller than 85 and 32. I have 35 written here for some reason. So the way we figure this out, instead of adding the two numbers, we're taking 85 and subtracting 32 to figure out the displacement and dividing it by the time interval. And that works out to 0.77 meters per second. So the velocity to get to this point, we're actually traveling a smaller distance per unit time. Now, instantaneous velocity is the velocity at any given moment in time. So if you have an object traveling for a period of time, its velocity could even be changing or it could be constant. If you want to know the speed right at this moment, we call that instantaneous velocity. And when I say moment, the time interval of that moment is infinitesimally small. So a good example of where we use instantaneous velocity is a car speedometer. The speedometer provides the speed right at that instant in time. So the speedometer is always determining that. If it's an old mechanical speedometer, it follows the speed of the vehicle. If it's a modern digital one, it actually calculates the speed of the vehicle. So an accelerating car, here's a graph of the velocity versus time of a car, and you see that with respect to time, the velocity is increasing, so the car is speeding up. And if we want to know the instantaneous velocity right in this moment of time right here, whatever that is, well, we're going to have to learn a little more, so stay tuned for a video showing how to determine instantaneous speed from a graph.